Everyone. We are now going to go over the peripheral blood flow cytometry from a 46-year-old man who presented with thrombocytopenia and numerous circulating blasts. And let's start with CD45 versus site scatter. Here we have a lymphocyte population that expresses bright CD45 and shows dim site scatter. And we have a couple of different colors here, and we'll see what those colors mean in the subsequent scattergrams. And here there is a large population that is painted blue that are sitting in the blast gate. Blast gate is defined by dim CD45 expression and low site scatter. And we could see that the cells in the blast gate are kind of continuous and have continuous with the cells that have very high site scatter. Normally, this gate that is cells that are painted yellow, this is the granulocyte gate, and these have very high site scatter and dimmer CD45 expression than lymphocytes and monocytes. So our blasts are kind of continuous with these granulocyte gated cells. And we do see an absence of cells in the monocyte gate. It looks like there are no monocytes in this specimen. So this looks like a B cell tube. It has markers CD19, kappa, lambda, CD5, CD10, CD38, CD200. So the cells in the blast gate that are painted blue, they are positive or partially positive for CD19, and they do not have surface light chains kappa or lambda. They are negative for CD5, and our orange population, which are CD5 positive, or the T cells that are in the background. The green and red population in the lymphocyte gate are the background polyclonal B cells that are CD19 positive, and the green population are the lambda B cells, and the red population are the kappa B cells. And the blasts are positive for CD38. It looks like there is some contamination with the granulocyte gate because there is no real separation. So some of these cells in painted yellow are also blasts. So they are positive for CD38, and the granulocytes are the neutrophils. This is peripheral blood, so we expect to see majority of the granulocytes in the peripheral blood to be mature neutrophils, and they are positive for CD10. So that's what we're seeing here. And CD200 is positive on the blast. And one thing to note, I want you to note, is the intensity of the CD19 expression. It's not like bright and homogeneous CD19 expression. It's a variable CD19 or partial CD19 expression. Now, when we go to the next gate, that is, again, we have a CD45 versus site scatter plot. Here, the lymphocytes are painted red. We again see the absence of monocytes. And here, the blasts are painted in maroon and aqua. And we'll see where these two colors are coming from. And the granulocytes are here in green. So the aqua population are the blasts that are positive for CD34. They are positive for CD38. They are positive for 117. They are positive for HLA-DR. And a subset of the blasts are positive for CD56. And that subset is what is painted as maroon color here. And our blasts do have a little high site scatter. And this is another gate with additional markers. Here, the blasts are painted in maroon, and these blasts express partial CD13. They're negative for CD11B. They're positive for CD33. They're negative for CD14. I'm calling this negative because, the green cells are granulocytes, and granulocytes are negative for CD14. And our blasts express the similar intensity of CD14 like the granulocytes. So sometimes, some markers can be noisy in flow cytometry. So you have to get used to what is the level of intensity that is usually positive or negative in whatever lab you're getting your flow plots from. And also you can compare the normal population that is usually positive for that marker to identify whether your population of interest is positive or not. For example, if you want to consider CD14, then your monocytes will help. But because there are no monocytes in this specimen, we cannot judge that. But we know that granulocytes are CD14 negative, and our granulocytes here express similar CD14 like the blast. blasts are negative for CD64 and they are negative for CD10. Now, let's see what the blasts are positive for in summary. They have dim CD45 expression, they're positive for CD34, the immaturity marker, and they're positive for the 117 and HLA-DR, and they are positive for the myeloid markers CD13, CD33, and they're negative for the monocytic markers CD64, 14, and 11B, and they're negative for CD10. They have a partial CD56 positivity, and they have high site scatter. They have a partial or a variable CD19 expression. Now, majority of the markers that are expressed by these blasts, like especially there is a bright homogeneous CD117 expression. So majority of the markers that are expressed by these blasts are myeloid markers. 117, 13, 33, these are all myeloid markers. The only thing that is different here is CD19 expression. Now, CD19 expression, we commonly see that in lymphoblasts or B lymphoblasts. But the intensity of CD19 that you see in B lymphoblasts is usually bright and homogeneous. It's not a variable partial positivity like this. If you see a partial positivity in B lymphoblasts, then you need to do additional workup to make sure those are actually B lymphoblasts. Now, there is an entity in myeloid leukemias which can express CD19, which is AML with translocation 821. So these 821 AMLs express partial CD19, and CD19 is not the only B cell markers they will express. They can express actually all the B cell markers like CVD79, PAX5. So, you know, even if you perform IHC, it's not going to distinguish the two populations. So the only thing that can help here is the intensity of CD19, and then there is a bright, homogeneous, unequivocal expression of myeloid markers. And also the morphology of the blasts help because they would be more of, you know, like the M2 or M3 blasts. There will be granules, they will have those salmon colored granules, and they will have sunset sign. All those things will help. But you need your FISH and cytogenetic studies, or sometimes even PCR, to classify this accurately as AML with 821. One other thing I want you to remember is AML with 821, AML with 1517, and AML with inversion 16. These are the three AMLs where you don't need 20% blast to call it AML. Rest of the leukemias, you need 20% blast, but for these three AMLs, you don't need 20% blast. So you can, I mean, if you know that it is 821 positive, you can just call it AML without worrying about the number of blasts. And other thing is CD56 expression. CD56 expression in these AMLs are of prognostic importance. So 56 expression is associated with poor prognosis in these cases. So for when you sign out these cases, you can call them acute myeloid leukemia with aberrant CD19 expression. And then in your comment, you can tell that the phenotype is suggestive of an AML with T821 translocation, correlate with FISH studies. And this also helps in the follow-up studies for minimal residual disease. Thank you.